Diving into a topic that confuses a lot of students when they first get into physics or engineering: kinematics versus kinetics. You've probably seen both of these words pop up in your textbook, or maybe your professor just dropped them like you're supposed to instantly know the difference between these two. But don't worry, by the end of this video, you will never mix these up again. Let's start with a simple idea. Physics has two main questions when it comes to motion: what is happening and why is it happening? Kinematics answers the what. It describes the motion. Kinetics answers the why. It explains the motion. Here is an easier way to picture it. Imagine that you're watching a car drive down a straight road. Kinematics tells you how fast it's going and how far it travels and how long it takes. Kinetics tells you why it's moving that way. Maybe because the engine's producing a certain force or because friction and drag are slowing it down. So, kinematics equals describing the motion, and kinetics equals explaining motion with forces. Alright, let's zoom in on kinematics first. When you're studying kinematics, you're looking at quantities like displacement, how far an object moves and in what direction; velocity, how fast it's moving and which way; acceleration, how quickly its velocity changes. In kinematics, we use equations to describe motion, not to explain it. For example, you've probably seen these two popular kinematics equations. These equations are all about what that motion looks like: position, velocity, and acceleration. But there's no mention of mass or a force. That's because we don't care what's causing the motion here. A kinematics problem might ask you something like, if a car accelerates from rest at 2 meters a second for 5 seconds, how far does it travel? We plug in the numbers into the kinematics equation: 25 meters. That's pure kinematics. It's just describing a movie scene without knowing anything about behind the scenes mechanics. You're just watching the motion unfold here with kinematics. Now, let's switch gears to kinetics. This is where we pull back the curtain and look at why that motion is exactly happening. Kinetics connects motion to forces and mass using Newton's second law, F equals ma. This is the bridge between cause and effect. Force causes acceleration, acceleration causes changes in velocity, and that gives us motion. Kinetics doesn't just describe what is happening, it gives us the physical reason behind it. It's the part of dynamics that says this block moves because there's a 20 Newton force pushing it to the right. In a kinetics problem, you might be asked something like this: a 5-kilogram object experiences a net force of 10 newtons. What is its acceleration? We solve it using Newton's second law. A equals F over m, which equals 2 meters a second squared. But notice something. Once we know the acceleration, we can plug it back into the kinematics equations to find how far it moves or how fast it gets. So kinetics gives us the acceleration, and kinematics tells us what happens because of it. They are like teammates. Kinetics explains it, and kinematics describes it.